conversation with some different people about Bitcoin again. And now I'm thinking about doing a live stream here and talking about the age of Bitcoin. Specifically, is it a young technology or is it an old technology? Like, would you consider Bitcoin to be something that's been around for a long time? Or would you consider it something that's brand new and hasn't really had its real heyday yet? Now, some people, most people maybe, would say, oh, it's already shot up in price and maybe it'll kind of go up a little more to $1 million. And then maybe that'll be it. And then the Ponzi will be over and it'll die back down. Per, come here. I got 2 puppies with me. So, let's think about it in terms of what it's actually designed to do and what it's already accomplished out of that. So we have BTC, which, if you know my channel, you know after August 2017, that's not real Bitcoin anymore, that's SegWit. So we're talking about real Bitcoin, which is before 2017 would be BTC, and then after 2017 they've been using the ticker symbol BSV. And some, for a couple months or something in 2017, I think the official ticker for the actual real asset was BCH, which is the ticker for Bitcoin Cash now. But that's still a different asset right now than the original one, which is, you want to just go with the addresses. So the addresses that start with 1, we're going to go with the longest chain of digital original signatures. I got 2 puppies that are chasing each other in the woods here. So, yeah. So I'm out in a nice place outside. I figured it's like a nice place to just walk around and talk about things. Got some nice nature around me. Nice weather. So, is it young or is it old? Well, let's just think about what is in Bitcoin's design that it has and has not done yet. Has it already expressed itself? Now, a lot of people might think, oh, it's already expressed itself. It's already traded all over the place. People are using it. So, I mean, it's already matured, essentially. And they might think that it's matured, but let's think about a few things, okay? So there's a few things about Bitcoin that I don't even see anywhere yet, but they're fundamental things. They're not just theoretical, future things, but these are fundamental things about Bitcoin that nobody's even really seen done yet. They might have tested it. They might have been shown in a few, examples, and maybe when they're testing Terranode or something like that, or developing some code and things like that. But nobody's actually practically used a few fundamental things that are in Bitcoin's design. One of those things is the use of a wallet in a change-like way. In a way that treats your coins like their pocket change. Okay, a lot of wallets, they don't do that. What they do is they combine everything into one key, and then when you want to send money somewhere else, it's all traced through that one key. Whereas when you have pocket change, remember, that's different. Because pocket change keeps a nickel by itself. It keeps a penny by itself. It keeps a quarter by itself. So if somebody puts a little serial number on a dollar bill or a serial number on a penny, and they're tracing where these are going, pocket change doesn't share the serial numbers. It keeps them independent from each other as coins. So you can get some coin from one source, you can send it to another source. You can keep that separate. You can say, okay, I got this from work, I'm gonna use it for work. I got these coins from my friend in this community, I'm gonna use it in that community. And puppy, come here. Come on. Come here. No, come here. Come here. We got friends walking by, so we got to make sure that our puppies don't run off and play with other friends. Puppy, come here. Come here. So right now, I don't see any wallets that really do that. That's not something that I see. We got a mommy here, and her son's over there playing, and we got other puppies that are wanting to walk by, and they want to go say hi to those puppies. So I'm gonna hold them here and let the other puppies walk by. So wallets don't really do that, but that's actually a fundamental thing that Bitcoin is designed to do. Another thing that it's designed to do, which I don't see anywhere yet, is Bitcoin is designed to allow mining to be separated from transaction verification. No, better no. Stay. Nope. No, don't. Leave that puppy alone. Don't bark. We're waiting for another dog to pass by so that my dog doesn't want to play with him so much. Yeah, we were waiting for him to pass by, weren't we? You stay. So that's something that I don't see happening yet. Now, theoretically, and in examples, it's sort of been done. It can be shown to work, right? So basically, you can have, say, transaction verification centers that are set up similar, I would want to say, to airports. Okay, there's not going to be too many of them, but they're going to basically be what people would call Bitcoin nodes, except they're not defined as nodes in the white paper. They're only part of the node process, and that would be verification. Okay, now they have, when you build a data center, data centers can't be built in 0.1 seconds and then deconstructed in 0.1 seconds, right? So if you're a data center and you want to have a reputation, you're going to have keys that you use to sign and say, hey, this is coming from data center alpha, you know, and you can use that to sign and say this came from here, so that somebody will pay attention to it and use it. So not only can they communicate with these other transaction verification systems efficiently, but they also can partially complete a block and then distribute it. And then what can happen then is all these people that have these little home heaters, you know, you plug it in, you heat up your room, right? That costs electricity. Now, if it's mining, let's say we're just talking about BTC now, not BSV. Let's say that can mine BTC, right? You're still going to use exactly the same amount of energy and produce exactly the same amount of heat, except now it's mining and it's producing heat, but it's not using any more electricity than a regular home heater, because that's how thermodynamics works. Okay, home heaters, don't go and buy a scam one that says, hey, our home heater is more efficient than the next one. Because unless a normal home heater produces a lot of sound, all the energy is going to heat. That's the thing. If you have a more efficient car, what's it doing less than a car that's less efficient? It's producing less heat, right? So if you have a heater, if it's less efficient, how is it less efficient? Is it producing more heat? I mean, that's what it's doing. It's producing heat. And the heat has to thermodynamically go somewhere. You don't need a fan to blow it off. It's gonna release the heat either one way or another. Okay, so unless it's doing something other than producing heat, which I can't imagine a heater is capable of doing, that's what it's gonna be used for. But so does a computer. A computer that's mining also produces heat. Now, if we're not talking about sending high bandwidth communications here. Okay, we're talking about just mining, which is the nonce checking part. Okay, so just the nonce checking part, that's a computational thing. Okay, it doesn't matter if you're highly connected, sending all transactions from here or there. Nonce checking is just nonce checking. It's just an expensive job. Okay, you can make it more efficient, but it's an expensive job at its core to do. And this is a core thing that Bitcoin is capable of doing. It's capable of separating these two concepts from each other and creating two different markets for those two different things. So you have two different markets. You have nonce checking, right, which is completing a block, and then you have transaction verification. And essentially what they can do is they can partially complete a block. They won't need any nonce checkers. They won't need all these ASIC machines. They can just be a data center that says, hey, we verified all these transactions. We have a complete block here. All you have to do is finish these numbers and you can pay yourself this final transaction. And when they pay themselves the final amount, both will get paid, right? Whatever fees were in that block. So they can basically split the fees with whoever they're sharing the nonce checking with. So they can do that. And then they can use the reputation, like I said, to if they need to do that, they can sign that. They can say, hey, there's a lot of spammy transaction verifications going on. And how do you filter that out? Well, if you sign it and you build a reputation saying, hey, I've never released something that wasn't a valid block before, and you're signing it every time you're releasing it, then you'll build a reputation. That way the miners are know. Okay, so that's just another, I'm getting too technical here, but that's another aspect, right? That's fundamental. Again, this isn't some side game thing about Bitcoin. This is a fundamental aspect about Bitcoin that has not even been seen by the world yet. So using it like change, like nickels, dimes, pennies, things like that, but even smaller or broken up into any size you want. And the traceability, the tracing of each of those being separated automatically by your wallet, which nothing new about this in the sense of theory. Okay, nobody has to invent something new to figure that out. It's able to be done, but somebody just has to create wallets to actually do it. Okay. Yes, there's billions of dollars worth of investment here, but only those who understand, only those paying attention to all the details and fully putting all this together with their marketing and their funding and all that stuff will really be able to profit from this, because there's either people with knowledge or people with money or people with this or that, and unless you have them together, you're not going to be one of those, making billions of dollars from this. But there is going to be some people out there, I can tell there's going to be some people who realize how this business works, and they'll be making these wallets and they'll be doing all these things. So you have the cash change aspect of Bitcoin, and then you have the mining market. Okay, the mining market, which causes the two different markets to stabilize with each other. And then what they do is they make Bitcoin extremely efficient, because you can already tell with the inefficient version, you already have miners who are mining BTC at a cost of thousands of dollars more per coin than the actual median or historical price of the coin. Okay, so you have, because when the option out there is, when you go to every single, say you go to every single person on the planet and you ask them, do you want to do this? Yes or no? It doesn't matter if 95% of them say no. If the 5% of them say yes, and they try to do whatever it is that you're doing for whatever price you're offering, okay, you're going to have some of them that are going to do it pretty cheap. Okay, you're still going to have a lot of people who will do it pretty cheap. So when you have an efficient system, then that makes it the other end now. So now you have BTC, which with the small blocks is exponentially less efficient, basically, because you're going to have a Sibold network. Okay, you have a lot of hops on the network, which is not good for double spend checking. I don't know how many times I have to repeat that. I keep having to explain this to everyone. This is the crux of whether you understand Bitcoin the true way, the BSV way, or the false way. Okay, you have to understand the double spend checking algorithm and what the network has to look like for that to work well. Okay, this isn't distribution of data. Okay, this is checking of data. That's two different things. Distribution of data means I don't care when this letter gets to its destination, it can take its time. Okay, checking means you have to make sure that this is when somebody gets this letter, I need to make sure that when they receive it, you've checked all the other letters on the planet to make sure that nobody else sent a letter, to make sure or to make sure that whoever sent the letter, say, didn't send another letter, you know, to someone else on the planet. You know, it's a completely different check. It's not distribution of just data. It's a completely different idea. It requires a high bandwidth set of nodes. So you can't just have a distributed network to do it. You have to have what I keep saying is like airports. They have to be like airports. They have to be highly connected with each other, and they can do it efficiently because they can separate the data out into Merkle trees. They can say, hey, anything starting with a 101, go over here. Anything starting with a 111, go over here. Anything starting with a 000, go over here. And they can separate it out like that. Let me read some of these comments here. We don't know what BSV can truly do. You are the guy in Reddit, bro. You are famous. I am not in Reddit. Is somebody either impersonating me or are people just talking about me in Reddit? Because I have not used Reddit for a long time. So, not sure what that is. Wallets need nodes. Nodes need electricity. Electricity needs capital. Okay, but here's the thing. That's true. And electricity, but you also want, it's also how efficient. Remember, look up the hash algorithm. Okay, look at how many universes can you create to hold tiny particles. Okay, how many, imagine how much work this is. Okay, 10 to the 1,500 power. If you simulate this little game that Conway, before he died, he made something called Conway's Game of Life. If you do this little simulation on a grid with these little ones and zeros that look like they're living creatures, but all they're doing is following a specific set of rules. If you do it in an inefficient way, it's so less efficient than the efficient way that you could take every little particle that you see on planet Earth, every proton that you see, every little molecule, and in 1 second you could say, using the faster version, I was able to do the whole galaxy instead of one molecule. Okay, I was able to process the whole galaxy instead of one molecule in a second. Okay, that's how much, it's so much faster because it takes advantage of not doing extra work that you don't have to do. And it's extremely good at that. It's so good at that's how much faster it is. Okay, because the amount of repeated work that's unnecessary is sometimes it's a lot more than what people think it is. And when you process transactions, when you're checking them against each other, that's how much better it is to separate things out into a Merkle tree than to try to check every transaction against every other transaction or something like that. That's why BTCers don't believe in Bitcoin, ironically, even though BTC was the ticker symbol for Bitcoin. They don't believe in it because they don't understand they don't believe that you can do that. And if they did, then they would understand that BSV would have to be the real. No, Peter, come here. Come here, Sis. No, go there, Sis. No, come on. Come here. Why did you go on the other side of a barbed wire fence? How am I supposed to take care of you now? You're not allowed to do that. No. She is such a naughty puppy. I think you have a playlist on your channel about this game. I don't know if I have a playlist. I know I have some videos about the game. Conway's Game of Life. It's just a simulation. Come on, Peter. Come on. Come on. How did you get in there? Don't make me call the fire department on you. You're crazy. How did you get in there? Come on, Peter. Come on. Come on. Come on. We're going to go there, Aziz. Come on. Come on. Come on. There you go. Good. She fit through the fence. Okay. You got me scared for a second. I was like, I don't want my dog being stuck on the other side of a locked barbed wire fence. That is not this is not going to make my day there. So BSV is capable of, I only mentioned 2 things in this video so far. Cash, as in change, and then mining networks that makes it even more efficient. Now, there's a lot more things, but my phone's going to run out of battery. So we're going to talk about those later, and maybe we'll think of some more things. But for now, I'm just going to leave those 2 out there and make the claim that nobody's really seen real Bitcoin work yet. So it's still young. It's still like a newborn. Because nobody's really seen it. It's like a fax machine when it's first being sold. Yeah, it works, but nobody knows who to fax because nobody else has a fax machine yet. They're just saying, hey, you want to get a fax machine in case in the future other people use them? That's it's sort of at that stage still. All right, so I'll talk to you guys later.